Hi everyone, my name is Tanvi and I'm here with my group members Varun, Stephanie, Warren, and Jamal. Today we will be demonstrating our tool which allows Emory Dining to schedule employees specifically for Cox Hall, the SAC Cafe, and the Rollins Cafe. Currently, Emory Dining struggles to rotate employees to fit their schedules and working hours. Some employees are unhappy with their schedules as they have to work back-to-back shifts with long work hours.
The employee will use our tool to indicate and rank which shifts they are able to work. We will be optimizing for employee satisfaction based on a ranking scale of 0 to 3. 0 being I cannot work, and 3 being I really want to work. Our tool will also ask the employees to rank the locations they prefer. 1 being I would prefer not working at this location, and 3 being I would prefer working at this location. Additionally, Emory Dining managers can easily access the optimized weekly schedule.
The front page of our tool has 3 buttons that an Emory Dining manager can use. The first button links the employee availability form to our tool. The second button allows managers to run the solver and create an optimized schedule for the upcoming week. Our tool will solve for the optimal schedule, but on the off chance that not enough employees are available to work a certain shift, a text box message will be displayed to the manager listing the shifts that require more employees to be scheduled. Finally, the third button allows managers easy access to the weekly schedule, showing the employee IDs of who is scheduled where.
On our second sheet, we have the employee responses for the availability form. This page automatically updates when a new calendar is being generated. This is done by identifying the most recent timestamp from each employee's response.
The updated schedule sheet is derived from the form results sheet. To ensure that employees are never scheduled for a shift where they ranked 0, indicating that they are not available for that shift, we replace all 0 values from the form results with a negative number. Therefore, when the solver optimizes for maximum employee satisfaction, we can be sure that their preferences are being considered.
This sheet shows our decision variables, constraints, and our utility functions. In our tool, the decision variables are the binary values representing whether or not an employee is working for each unique combination of shifts and locations. We have a few constraints, including the required number of employees in each shift per location, that is 2 at Rollins, 3 at SAC, and 4 at Cox. We also have the minimum and maximum number of shifts per week for each employee, with the minimum being 2 and the maximum number of shifts being 6. We have the consecutive shift constraint that ensures employees are not scheduled for the morning and afternoon shifts on the same day. And finally, we have the single location constraint, which ensures that employees are only scheduled in one location at any given time. Our objective function maximizes the sum of aggregate employee shift utility and aggregate location utility. This function maximizes employee satisfaction.
Now we will show you what happens when our tool is run. After performing optimization of employee schedules, you will be automatically taken to the optimized calendar, where employees are designated by their ID numbers.
3 days later. 15 minutes later. Thousands of tears later.
As demonstrated, our tool efficiently and smoothly helps Emory Dining schedule employees for shifts at Cox Hall, SAC Cafe, and Rollins Cafe, while allowing for the prioritization of their preferences for shift times and location. All in all, this tool will help Emory Dining improve employee satisfaction, increase productivity and motivation at work, and subsequently result in higher profit levels.